So here we can see that for argon it is 18, so it's going to be 1s2, 2s2, 2p6, 3s2 and 3p6. So now here the first shell is having 2 electrons. For neon, the first shell is having 2 electrons. The second shell, that is n equal to 2, is having 2 plus 6, 8 electrons. Similarly, argon, the first shell is having 2 electrons. The second shell, that is n equal to 2, is having 8 electrons. And the third shell, that is n equal to 3, is having 2 plus 6, again 8 electrons. So now here you can see that the noble gases, the noble elements has completely filled shells. Okay, they have completely filled shells. So this sort of the shell where all the 8 electrons are filled, that is it is filled with 8 electrons, is called as octet configuration. Okay, this is duplex configuration, duplet configuration. So these sort of octet configuration and duplet configuration gives stability to the atom. So this duplet configuration, octet configuration gives stability for an atom. So now what happens in this noble elements? Since the shells are completely filled, it does not allow other elements to react with it. It does not either take electrons from other elements nor give its electron to the other element. So therefore this sort of noble elements do not react with other elements. They do not react with other elements. So now say for example elements are not the shells of an element are not completely filled. Then what happens? To reach the stability, they need to have 8 electrons. So they will go to other elements and try to take electrons from the other elements. So the other elements which do not have this octet configuration will interact with other elements. So when 2 atoms or 2 elements interact, they are going to bond. That is what is called as chemical bonding. So now these chemical bonding, we have 2 types actually. In a chemical bonding, there are 2 types. One is ionic, another one is covalent. So let us study this one by one. So let us first go for ionic. So in ionic, what happens? Where does it take place? So ionic usually takes place, it's a bond which takes place between a non-metal and a metal. Okay, so best simple example is NaCl, sodium chloride. Sodium is a metal, chloride is a non-metal. Okay, so this is a non-metal. So this is usually ionic bond takes place between a metal and a non-metal. So you can have other things like potassium fluoride, you can have many, magnesium chloride, so you can have many things like that. So now what happens in this ionic bond is that one element will transfer its electron to the other element. Okay, so there is a transfer of an electron. So let us understand this with an example. So I am going to give an example as potassium fluoride. Okay, so let me go an example I am going to give. So that is going to be potassium fluoride. Okay, so now potassium is a metal. Okay, so fluoride, it is a non-metal. Okay, so it is an indication that there is an ionic bond. So now what about potassium? Potassium atomic number is actually 19. Okay, so what is the electronic configuration? It is going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So what is happening? First shell is having 2 electrons, second shell is having 8 electrons, third shell is again having 8 electrons, and the fourth shell is having 1 electron. Now let us come to this fluoride, that is F. So F is having 9 atomic number, so it has 9 electrons. So what is going to be the electronic configuration? 1s2, 2s2 and 2p5. So the first shell is having 2 electrons and the second shell is having 7 electrons. So now both potassium and fluoride will try to obtain the octet configuration because they have to reach the stability. So this is having, if this potassium will give away this extra electron, it's going to have the octet configuration. Now if you take fluoride, if it takes this electron, then it is going to get 2 and 8, so it's going to get the octet configuration. So now what is happening? Let us write it with the Lewis diagram. Okay, so now I'm going to represent only the valence electron. I'm going to write, that is the electrons in the outermost shell. So potassium, I'm going to represent this electrons with K, that is cross. It is having 1 valence electron. Then we have fluoride, it is going to have 7 valence electron. So it is going to be 1, 2, 3, 4, 5, 6 and 7. Now what is going to happen? When they are bonding, this electron from potassium will get transferred to the fluoride. So what is happening? This potassium is going to lose 1 electron and it is going to become positively charged. And that electron is going to come to the fluorine element. So it's going to be like this. Now this fluoride has gained an electron, so it is going to be negatively charged. Now what is going to happen? This is positively charged ion, this is negatively charged ion. There is going to be an electrostatic force and there is going to be an attraction. So this attraction will actually form this compound. This is an ionic compound. Now what about covalent? Covalent does not transfer the electron, they are going to share the electron. So in covalent, what happens? In covalent bonding, so this bonding usually takes place between a non-metal and a non-metal. Okay, I'm going to explain that non-metal with an example. So here what happens? Transfer of electron do not take place, sharing of electron takes place. Here sharing of electrons takes place. Okay, so let us take an example. I'm going to take chlorine diatom as the example. So how does 2 chlorine atom form a diatom? Okay, so I have chlorine Cl2, which is a diatom. Okay, di means it has 2 atoms, 2 elements of chlorine. So this chlorine is actually a non-metal. It is a non-metal. So now what is happening? So now chlorine, that is Cl, is having an atomic number 17. So what it's going to be the electronic configuration? It's going to be 1s2, 2s2, then 2p6, 3s2 and then 3p5. Okay, so now first shell is having 2 electrons, second shell is having 8 electrons and third shell is having 7 electrons. So it does not have octet configuration. So it has to take an electron from another element to get that stable octet configuration. So now what happens? I have 2 chlorine atoms. So let me write chlorine. Okay, first chlorine. So I'm going to represent only the valence electron. So for the first chlorine, I'm going to represent valence electron with cross mark 1, 2, 3, 4, 5, 6 and 7. It has 7 electrons. Then the other chlorine element, it is also going to have 7 electrons. I'm going to represent the electrons as dots. 1, 2, 3, 4, 5, 6 and 7. So 7 valence electrons I have represented here. Now these two are going to bond. How they are going to bond? They are going to share the electron to reach the octet configuration. So now what is going to happen? I have chlorine, so it is going to share. Okay, so now let us see what is going to be the electrons number. Okay, now take this chlorine atom. How many electrons it has? 1, 2, 3, 4, 5, 6, 7 and 8. Now this chlorine atom, how many electrons? 1, 2, 3, 4, 5, 6, 7, 8. So what happened to the configuration? It became 2, 8 and 8. Okay, so it had reached the octet configuration. So by sharing electron, it is going to actually reach the stable octet configuration. So this is about covalent bonding.